We are going to be given tables of values, and we are going to find our rate of change, and we're also going to find what we call our initial value. An initial value means like the zero, where it starts at, 0, okay? So, here we go. Here's our plan for this. We just have to find our rule, our rate of change, and then our initial value. So the two things that I care about with you right now, and I'm going to introduce that, is my rate of change. There's a symbol, triangle. Triangle means the change. I think it's a science symbol, and it's a math symbol as well. When you see a triangle, you can also say it's the word change. Rate of change. So I'm just going to use triangle. Okay. How does my y change?
1.
Okay. But I'm adding. So my y over my x. How does my x change?
1.
Well, this is so easy, right? Okay. Initial value means when the domain is 0, what is the range? We also call that the f of x. So this is where I'm looking right now. See how I circled in blue, 0 comma something? My rate of change is 1 over 1, y over x. My initial value, when my domain is 0, what is my range? What's my initial value?
4.
4. Okay, good. That's all we're doing for these first 5 problems. Figuring out what's the rate of change and our initial value, our 0. Second one, I need to know my rate of change and my initial value. Okay. How does 5 become 9? How does 9 become 13? How does 13 become 17? Plus 4, plus 4, plus 4. How does 0 become 2? How does 2 become 4? How does 4 become 6? Plus 2. My y changes because I'm adding positive 4s. My x changes how? 2s. Can you reduce that for me? You could just say 2. You know, either way. What's my initial value? My 0.
3. Wait. Oh, wait. No.
Okay. Good. On to the next one. Are you thinking this is easy?
Yeah.
Okay, then, good. Do it with your partner. Add 3.
And your x is add 2.
Add 2.
So that's 3 over 2.
Okay, Miss Wolf, what is my initial value?
3.
3. Okay. 5. Ooh, there's no 0 here. What are you going to do?
You go down an extra 1.
Go down by 1.
Just make it 0 something. So like write it in yourself. Just fill it in. Okay. Okay. Right here. I know that you've been absent, but I'm sure you can pick up on it. So maybe the two of you want to answer. What is my, hold up, rate of change?
1.
1. Okay, 1. What is my initial value?
3.
3. Agreed? Yes, no? She's right. All right, then. I'm going to call in a group. So, what is my rate of change? -2 over 1. What was my initial value?
13.
You guys had to go all the way there? 2, 1, 0. 9, 11, 13. Okay. Cool. Looks good. Okay. I'm adding one more step now. I'm actually going to put together and combine the rate of change and the initial value into a function form. Function form. Let me just do it on the side over here. Function form, or you can do it in your margin. F of x equals I have to do it. So, rate of change is going to be my m. And I know you've seen this before. Initial value is going to be my b. The x is going to stay there. It's always going to be an x. F of x will always be there. It's your rate of change and your initial value that are going to be plugged in. Different numbers every math problem. So the blue m and the blue b, that's what you're going to be plugging in for initial value is your y-intercept is your 0, something. And then your rate of change is going to be, you're going to plug that in for m. Okay. How does 10 become 11? How does 11 become 12? How does 12 become 13? How does 13 become 14? Plus 1. How does 0 become 1? How does 1 become 2? How does 2 become 3? How does 3 become 4? What's my initial value? 10. So here I go. F of x, function form, equals 1x plus 10. See how I kept it in blue and black? Just so you knew that this 1 and this 10 are the things that I plug in. Function form. I use my table of values to figure out how to write my function. Everyone got this one copied? Do I need to slow down or speed up or what? Okay, now go to C. So I'm skipping all around. Stay with me. Now I'm at C. I did not do B. All right, how does 20 become 18? How does 18 become 16? How does 16 become 14? -2 over 1. Oh, my initial value is not there, darn it. But I could make it 0, 22. Okay. F of x equals my rate of change. I don't even need to put over 1. X is just part of the function formula plus 22. Okay, now I'm not going in order. Remember this. So let's move on. I'm going to 2A and 2C. Jump down to 2A and 2C. Okay. The directions say find the domain. It does not say find the rate of change. It does not say find the initial value. It says find the domain. So, how do I know whether this is going to be like a straight line that continues on forever? Like, how do I know if it's a function or not? Where's the domain? What do I do? What do I do? What do you think? Yeah?
You plug in all the numbers for x, or
But I don't have an equation for A. What do I plug it into?
c.
No, A and C are totally different problems.
Oh, okay.
If I'm just given a table of values, how do I find the domain? What do you think I might do? Let's just play around with ideas. Look at the x values. 1, 2, 3. Okay, so those are all different. So that means that it's a function, right, so far? My 3's repeat. What's something I could do? Let's play around with ideas. I could make an equation.
You can graph them.
I could graph them. Oh, both great ideas. I'm going to do them both. Equation, and then I'm going to make a graph. So I could make an equation by doing my, problem. My, remember how yesterday it had to be like a consistent change? How if my rate of change wasn't in a regular pattern, I mean, this is not going to work. Let's go to graphing. 1, 1. Hold on, let me do this. 1, 1. Here. 2, 3 over 2 of 3. 3, 3 over 3 of 3. What? So, first of all, if I had to draw a line, it'd be like, but it does pass the vertical line test, you guys, so far. It starts and it stops. So based on what we're given, I can't say all real numbers. The problem is that there's not a pattern going on here with these 3's. Like all of a sudden it throws us for a loop. And it's like, oh, same number in a row. So we couldn't make an equation. Let's do our domain of writing the numbers. 1, a 2, and a 3. That's our domain. Okay. Let's jump to C. That's fine. A is fine. C. Is it just so, whenever you have just a normal equation, you guys, it's always all real numbers. So it's like a giveaway. I'm not going to make you graph it because we don't know how yet. I'm not going to do table of values because we don't have a table of values. Whenever it's just a normal equation, I could plug in any number for x and it's going to get out a different domain. So the domain is all real numbers. I could plug in any number. 1, 2, 3, -5, -6, -7. Anytime it's just a normal equation, the domain is going to be all reals. Okay, now let's go to E. Jumping down. Drop down. We've seen fractions before. Remember that rule? No 0 in the denominator. I do not want 0 in my denominator. So tell me, what would I put in the denominator to make the denominator a 0? 0. So here it goes. My domain could be any number. However, it cannot be 0. This is flashback from last week. Remember this? Okay. I'm moving on. Find the domain, go to G, turn the page, go to G. The only thing I care about is if there's a number that would make, the denominator of 0. But I don't really have, I just have to multiply 1/2 times any number I can think of. I could put in any number in the whole world for x, and I could multiply it, cut it in half, and then subtract 3, and I'd get a different number. So I'm again going to say that it's all real numbers. It's only when there's like a special denominator, that's when you have to do your 0 rule. Okay, looking here, this starts and stops. This is not arrows that make it go on forever and ever. Does it pass the vertical line test?
No.
So we know it's not a function. But look at where it starts and stops. 0. And it ends at 5. Right? My domain is in these blue lines, in between these. How do I write it when it's like in between? What's that special way? That in between. Yeah.
0 is less than or equal to x,
X because it's the domain. If it were range, you'd say Y.
and greater than or equal to 5.
It goes the same direction.
Or less than.
It's still less than or equal to. It's like a pattern. They're both less than, less than. Yeah. Oh, but 5's an open circle?
Yeah,
5's an open circle.
so it's just equal, it's just small.
So weird. We haven't really talked about that yet. But since it's an open circle on a graph, it means that 5 is not one of the solutions, but 4.9 is, 4.8 is. So that's kind of a weird one, but we have no problem introducing new material. K, starts and stops. Solid, dark dot, in between what? What is X in between?
-2 and 4.
Good. All right, number 3. Eva biked 100 miles in 5 hours. Find the average rate of change in miles per hour. Okay? So that means that in 5 hours she biked 100 miles. Rate of change is very similar to unit rate. I talked about it yesterday. I want to know how long it took her to ride her bike 1 mile? Or do I want to know in 1 hour how far she got? 1 hour how far she got. That means that I'm going to put my hours on the denominator and my miles on top. The per hour, whatever word is after per, that goes on the denominator. Okay, what is her 1 hour timing? 20. That means that she rides her bike 20 miles an hour. So in 1 hour, she goes at a pace of 20 miles per hour. Just for reference sake, when you're watching a professional race, those men or women who are racing go, if it's flat ground, for sure they can easily maintain like 28, 29, 30. Their legs are just going. So 20 miles per hour is still decent, but she's working, she's not slacking off. All right, go to 5, please. The average amount for room, board, and tuition at a public four-year college was $17,447.06, $21,189 in 2010. Find the average rate of change. What's the best way for me to organize this information?
Subtract both of the prices.
I need to organize the information first before I do any math. A chart. My brain might be stuck here. Where does the year go and where does the money go? It's the same issue. Whatever goes on the bottom, that's what I want to know one of. Do I want to know $1 or do I want to know 1 year?
1 year.
1 year. So that means that you're going to put year on the denominator and you're going to put money on top. Year is going to be your X and money is going to be your Y. Year, 2006. Year, 2010. In 2006, let's fill in my chart, $17,447. If someone has a calculator in their backpack, could they take it out? In 2010, $21,189. How much money did it increase from 17,447 to 21,189?
74.
Okay, somebody's voice needs to be clearer. I heard the 3,000.
3,742.
From 2006 to 2010, how many years went by?
4.
4. I could maybe reduce that fraction to find 1 year. Each 1 year, how much did tuition rise?
$935.
Wait, $935.5.
And 50 cents? Okay, approximately $935. Okay, every year the college tuition rose $935 a year. Okay, we answered our question. Find the rate of change. $935.50. That's my rate of change. That's how it's changing. Okay? Cool. So here's how the rest of this is going to work. Everything that I did not do with you in class is going to be your homework. So all the rest of the work, and I wrote it on the board here. Number 1, B and D. Number 2, B, D, F, H, J, L. Number 4 and number 6.